The headline says, Germany wins a $10 billion victory for tech autonomy with Infineon's new Dresden plant. But what if that factory cannot turn on? Modern chip fabs are not just clean rooms, they are industrial power plants and water treatment facilities disguised as high-tech labs. This story reveals why this facility faces an immediate engineering cliff where the local grid cannot handle its load, groundwater is drying up before production starts, and summer heat threatens to melt their cooling systems within months of opening. We often imagine a chip factory as a pristine white box floating above reality, immune to the messiness of the outside world. In this view, if you have the money and the land, you can build anything instantly. The narrative suggests that policy announcements are enough to summon technology from thin air. But the physical layer does not care about political will or geopolitical strategy. It cares only about physics. A modern semiconductor fabrication facility is a massive industrial utility requiring specific geography just as much as it requires clean rooms and expensive lithography machines. You cannot build a Formula One car on a dirt track. Similarly, you cannot run advanced chip manufacturing in a location that lacks the fundamental resources to support it. The first killer of this autonomy project is water. Modern semiconductor fabrication requires millions of liters of ultra-pure water daily for wafer cleaning and etching processes. This is not a small amount of fluid, it is an industrial river flowing through pipes every single day. The Dresden site in Saxony is currently experiencing severe groundwater depletion due to chronic drought conditions. There is now a fundamental supply mismatch between the plant's physical needs and local availability before construction even finishes. When you try to extract millions of liters from a region where the water table is already dropping, you are not just building a factory, you are fighting against the environment itself. The physics here do not negotiate with budget spreadsheets or political deadlines. Quick resource note, I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Then, we must consider the power grid. Advanced chip manufacturing requires continuous, uninterrupted power cycles with zero tolerance for fluctuations. A single spike or outage can ruin entire batches of wafers costing millions in seconds. Regional data indicates that Saxony's grid lacks the necessary redundancy to support this load reliably. The facility demands a stability and capacity that simply does not exist at scale in the current regional infrastructure. If the power flickers, the delicate chemical processes inside stop dead, leaving behind worthless silicon. This makes local grid stability a critical failure point rather than an afterthought. You can buy all the equipment you want, but if the utility company cannot guarantee steady flow 24 hours a day, 365 days a year, the factory remains silent. The third physical constraint is heat. Fabs generate immense heat that must be dissipated instantly via complex cooling loops to keep sensitive electronics from melting or failing. Dresden's rising ambient summer temperatures threaten to overwhelm these systems completely. If the outside air is too hot for efficient heat exchange, the facility risks thermal shutdowns precisely when production yields are highest. The equipment generates so much energy during operation that without a cold environment to absorb it, the internal temperature rises uncontrollably. This creates a critical bottleneck where cooling could fail before yield targets are met. It turns a supposed geopolitical victory into an engineering nightmare where the very act of making chips destroys the ability to keep them running efficiently. This situation exposes a deep gap between policy and physics. The project represents a $10 billion investment aimed at reducing reliance on Asian supply chains, which is undeniably a political win for European independence. However, it ignores the physical layer constraints that make modern fabs location-dependent. Building in a region without sufficient water or stable power is not just expensive, it is physically impossible to sustain high-yield manufacturing under current climate conditions. The irony is sharp. We are trying to solve a supply chain problem by building infrastructure that cannot function within its own environment. This reveals why reshoring hardware feels so much harder than software. We often assume that if you allocate the funds, the technology will appear. But for physical goods, geography dictates what can exist where. The constraints of water scarcity and grid capacity are hard limits that no amount of political rhetoric can engineer away. Whether it is a chip fab in Germany or an energy storage facility elsewhere, these factors dictate the boundaries of our technological future. We cannot simply wish away the need for cooling or fresh water by declaring autonomy. We must build the infrastructure to match the engineering reality first. If Dresden struggles with these bottlenecks, what does this mean for the rest of Europe's chip ambitions? It suggests that without a massive parallel investment in utility upgrades and climate adaptation, new facilities will face similar silent failures. The lesson is clear: you cannot engineer away physics. When capacity tightens, the constraint is rarely a missing app feature or a software bug. It is the lack of water flowing through pipes or electrons moving steadily across a grid. Understanding this shifts our view from asking who made the chip to where on Earth we can actually make one. The future of technology depends less on policy announcements and more on whether we respect the hard limits of nature before we lay the first brick. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.